In this video, we're going to have a look at parametrics. Now, parametrics is an Extension 1 topic, or a 3-unit topic, and it builds up on the topic of Locus and the Parabola that we saw in 2-unit. Okay, so let's remind ourselves what a parabola is. A parabola is defined as the locus of all points which are equidistant from a point, which is called the focus, to a line, which is called a directrix. The focus has coordinates 0, a, and the directrix has equation y equals negative a. And of course, a is called the focal length. Okay, so if I have any general point on this parabola, I want to be able to express this point. So let's take a point, a general point P. Now, how can I express this? Well, I can use what is known as the Cartesian coordinate, and that would be simply a point x comma y, but x1 comma y1, sorry, but not any point x1 comma y1. There has to be a specific condition, and that condition is that x1 squared equals 4a y1. And this obviously makes sense because if this point lies on the parabola, it must satisfy the equation of the parabola, and so this is where I get that condition from. Now, alternatively, we can express it in parametric form. So the parametric coordinate is going to be 2at at squared. And this is for all t, for all values of t. So for every value of t, I'm going to get a point on this parabola. And every point on this parabola has a certain value t, which will give me this point P, which lies on the parabola. Now, how can I be certain that this thing here really is a point on this parabola? It's always going to be a point. Well, this is really saying that x is equal to 2at and y is equal to at squared. So I have these two equations. I want to eliminate t, which is called the parameter. So if x equals 2at, then I can say that t equals x on 2a. Now I can substitute this value into y equals at squared and see what I get. I'll get y equals a times t squared, but t is x over 2a. So I have a times x squared divided by 4a squared. Now 1a here will cancel with 1a here, so I'm left with 4a in the denominator. If I multiply that up, I get 4ay equals x squared, which is the equation of my parabola. So therefore, clearly this point here is always on the locus. We recover the equation of the parabola. All right. And so parametrics is very interesting. We'll see some really great things. We'll see how to find the equation of a tangent at a point P. We'll find the chord, the equation of a chord, of focal chords. We'll see certain properties about parabolas and use those to solve problems. And it's really a great topic. So I hope you enjoyed this small introductory video. Thanks for watching.